All right. Good morning, everyone. Morning. Hi. How many of y'all are regular attendees of this meetup? Wow, nice. So y'all are all Cube fans, right? Okay. So welcome again, and thanks again to the organizers for inviting me. I'm Dharmesh Vaya. I work as a solutions architect at Palo Alto Networks, and happen to be working with a platform called Prisma Cloud, and a bunch of other technologies. Been with the industry for almost now 18 years, and yes, have had a host of other diverse experience, whether it's development, Python, Java's, security, probably a bit of AI nowadays. Yes. So what we are going to do today is, a very basic introductory talk, right? It will have, shades of certain advanced concepts around demystifying three Gs of AI, right? AI is still booming, right? It's still in a 2G, 3G state. So three Gs are Gemma, Google Kubernetes Engine, and which is the third one? Gemini, right? Or GPUs. Okay. Right. So first of all, let's try and understand very simple concepts, right? Why GPU? Why GKE? And why Gemini? Anyone? Let's make it probably interactive. Anyone is using any of these combination of technologies? Anyone using GKE? Okay, let's start with number one. Yeah. Okay. No GKE guys. Okay. Kubernetes. Good. Okay. What's the difference between GKE and Kubernetes? Managed services. Yeah. Okay. So you get some benefits out of that. Yes, but खर्चा भी होता है. Correct. हाँ, ठीक है. Right. So okay, so let's have a very quick view of what can GK do for you, right? It has certain advantages, as the gentleman said, right? Manage Kubernetes, right? I don't have to worry about the entire infrastructure now with autopilot. All the scaling and all can happen by itself, right? So auto scaling is something integrates very well with the entire GCP ecosystem. So again, I mean, that's just a statement to kind of highlight that when I say integration, right, not just GCP but with a host of other ecosystem as well, right? Since it is heavily automated, it is API based, you can use integrations with other ecosystems as well, even if it is something like an on-prem thing, right? So number one, GKE. Now the reason why we are talking here about AI with GKE is that we all understand that AI is going to require a lot of compute. Correct? Agree or disagree? Agree. Okay. Now, since it requires a lot of compute, correct? The best possible way, and everything, I mean, the world is going towards, it was going towards containerization. It has probably matured into a containerization mode, right? And that is where GKE would be possibly the best possible compute architecture for AI systems. Agree so far, right? Second, why GPU? Anyone? Why can't I run it on my traditional ARMs and Intels and stuff like that? Why can't I run AI systems on? Why does it require GPU first of all? Sorry, anyone? Oh, you're reading from the answers, right? Okay, fine, fair enough. Good. That was the intention, right? So yes, so well, in terms of AI systems, right now the idea here is, you can read these three bullet points, but the overall idea or the overall perception with AI systems is the fact that you need a lot of computational power, and that too in a parallel mode. Now if you do it with your Intels and ARMs and stuff like that, right, you are going to require massive amounts of parallel processing for compute, and the cost will be way too much, way extremely high. You probably can achieve, but it will not be efficient. That's number two, right? So if you see, from the cost effective side of things as well, right, GPUs are highly cost effective, and of course you will have cost benefits if you are holding Nvidia shares, right? That's the other part, right? So GPUs, again, if you are going ahead with a kind of deployment architecture, if you are able to run now Kubernetes or GKE, whether in autopilot or standard doesn't matter, right? You have now GPUs available as the standard compute options as well, which makes it now compatible to run AI workloads. Getting it so far? The connections, right? AI, GKE, GPUs. What is next? Gemma, Gemini, whatever, right? Why Gemma now? Okay. Now look, Gemma is I would say I mean, leaving apart the commercial aspects of Google or anything, right? It's a kind of a model, right, which has several text processing capabilities, right? Number one being, of course, text generation. We all are kind of probably now slaves to chat GPTs and Geminis and Gemmas and all, correct? But if you have to make it enterprise grade application, right? Are you going to build everything from scratch? Not really. Or are you? Anyone? Anyone has a misconception? You are going to build everything from scratch? Probably the data sets and your model is something that you will build from scratch. Right? I think even there you're going to use a lot of boilerplate and then just train your data. That's something that you are only going to do. Right? The ability to do natural language processing, right? The ability to do Q&A, the ability to do classification, right? Or probably even code generation, right? That is what Gemmas and Geminis of the world have it inbuilt, right? You don't have to worry about all these feature sets or use cases, correct? What you have to worry about is basically what is your business use case, whether it's for retail, whether it's for healthcare, for fintech, finance, whatever, correct? You should be focusing on your training data sets and the model inference that you want to get out of it. Make sense? Okay. Now, what about a term called VLLM? So I'm not sure if you all read the description which I had, right? I mean, when probably in this meetup description, I had mentioned a word, right, called VLLM. Anyone is aware of VLLM? What does it do? What is meant to do? Anyone? Okay, what is LLM? Fantastic. What is V? Virtual, correct? That's the simple answer. Okay, but if you look at I mean, don't get bogged down by this text. It Some of it can be auto generated, so leave apart that. Let's assume, right, leave apart the fact that you understand what does LLM do. What does it do? Processes natural language. Okay, so if I have to put it in a nutshell, right, let's say you are a student. Okay, that student is an LLM. Okay, and you are reading a book, right? You are going to read it word by word if you are a good student, correct? And you are going to read it thoroughly, you are going to read it completely, and then when I ask you anything out of it, you will say, okay, hey, this was the page where I found your answer, correct? That's what LLM is supposed to do. Now, imagine virtual LLM, okay, to be that robotic student, okay, who is going to write or know everything, and he is going to make bookmarks everywhere. Understood? He's going to make bookmarks everywhere so that when I say, okay, hey, what was written in chapter XYZ, he'll say, okay, I have a bookmark for that. Let me go and easily search that, right? That's what VLLM is going to do for you. So if you see this, right, there is something called as different worker nodes, right, which are actually breaking down your data, okay, into bookmarks. And okay, that is where VLLM is going to be highly efficient. So if you see this particular flexibility and ease of usage capabilities, right, it so of course, I mean, all the integration capabilities are one side, right? But if you look at how it does the indexing, right, the indexation part is most crucial of how VLLMs operate. So far all good? Any questions? Okay, it was easy, right, so far? Right? We are just like few blocks here and there, and then now let's make it complex. Okay, what is a RAG system? No full forms. Okay, correct. Okay, what is a vector? It's an array. Correct. Yeah. So you are basically, if there is a whole, encyclopedia. Correct. Let's take a same example, a book, a student. Okay. And you are breaking down things. Correct. Now, what does RAG do over here? Okay, is the fact that if you have to kind of, so the student as such, right, consider him to be that serving system, right, and then he has memorized, okay, which page belongs to which chapter, which para is which section is in which page, and so on, right. So all that paging and indexing has been done by that student. Correct. What RAG does, RAG is that brain of that student, which is helping it do it in a very structured and a methodological manner. Make sense? Right? Usually, in most cases, I would say 90-95%, I would say RAGs, okay, are going to have two subsystems, serving and embedding. Okay. What does the, so this is what the architecture of a typical RAG system will look like. Right now, I don't like to use the word rag. It's used in different ways, so I'll keep on telling RAGs, right. So the serving system, right, okay, it is meant to interface with the user from a request response perspective. I would say, okay, so y'all use chat gpts and geminis, right. The interface that you are using, right, that's the serving part. But behind the scenes, right, there is someone sitting behind, right, not really humans, but a ton of servers or databases and stuff like that, right, which are actually doing the searching part for you or retrieving the information for you. That is something which is the embedding system. Now the job of that embedding system, okay, is basically to ingest the data, right. It could be from the entire internet, it could be from specific search modules, it could be from your databases, it could be from your s3 buckets or gcp buckets, wherever they belong, right, and then keep on training the data. Correct. Now, this search data, okay, it has to be converted into vectors for the embeddings to kind of let it search, okay, and then you store those embeddings into the vector database. So that is the role of the embedding system. So if you see this particular flow, right, it could be external or internal sources, raw data stored, cleaned up, processed into the embedding service. Embeddings are stored into the vector. So who is from the way you are searching, are you directly searching on this external source? No, it has to be kind of indexed. That bookmarking part which I was talking about, right, is happening somewhere over here. Okay. Here it is mainly, okay, the request response and the inference server, right, which could be used to again retrain the models and so on. So far all good? Yeah. Okay. The same one, a magnified view, a little bit complex. Okay. What do you see here? Container fans, Kubernetes fans. Where are the kube fans? Yeah, you see, front end server could be a Kubernetes, a GKE cluster. Your inference server could be a GKE cluster. Yeah, your embedding service can be a GKE cluster. Okay, these could be third-party databases, cloud storages, SQL, IS3 buckets, anything, right? The functionality, the flow remains the same, correct? It's just that, how you are orchestrating it. Now, this is a very practical use case of how, search, or how you can say chat is used, okay, for like AI in actual retail use cases. So let's say, if without taking names, right, large retailers, something like Pantaloons, Westside and stuff like that, if you have seen their chatbots, right, okay, behind the scenes something of this is being used. Correct. They have a huge database of products, they have a huge database of inventory, okay, and they want to search, okay, hey, where do I find an xyz trouser or xyz shirt, right? They'll say, okay, it can be found in this particular section, right, and then you can go ahead and probably search in that store and so on, right? So all that features and functionality can be achieved via this architecture. Now, where is Gemma? Where is Gemini? Sorry, this one, right? The inference part, correct. This is the Gemma part of it, right? Because now what exactly Gemma is helping you do it, is the fact that it is readily giving you, okay, all the framework to kind of process that text or manipulate that text or generate some text out of it, correct? Also, if you see, there is something called as contextualized prompt. What is contextualized prompt? Have you all tried playing around or breaking prompts? Anyone from a bit of a security background? Yeah, you've tried breaking around things, on chats and the chat GPTs of the world. Any red teaming that you have tried? Okay, on the network side, right? But what about prompt manipulation? Okay, yeah, you should probably take a look at that. And if you, I mean, just a deeper learning for you will be the OAS top 10 for LLMs, right? There's something around prompt manipulation, prompt injections, and stuff like that, right? And yeah, probably I work closely along that, so that helps. Yeah, you want to say something? You tried doing that? Okay, so API keys is again, I would say on the infra side, without having an X. Okay, using the prompt, you have got the perfect. Yeah, that's what the intention is, right? So that there are two aspects to that, right? One is getting through the API keys or the infra sensitive components, or okay, or the from the prompt itself you get, a data which it shouldn't have been throwing up, right? So that is where, even the responsible AI services come into picture, right? So why I'm highlighting these facts is when you build an RAG systems, right? It's not just the infrastructure that you should be worried about, not just the data that you should be worried about. The mindset also has to be a bit inclined. If you are working like 100%, right, 25% you should be thinking around security aspects as well, right? So especially with the kind of data these days that is available, whether you call a financial data, personal data, and so on, right? In fact, that's where we are heading into. We might soon have our own GDPR based systems with DPDP coming in, right? So that is where, the RAG systems can be built in this manner. We can go a bit more deep dive into it, right? What exactly is the job or the role of this embedding system? Now, I explained that, the data is getting stored into, some of the storage accounts or databases and so on, right? But the idea here is, right, the main component or the main crux over here, okay, is what is this embedding service meant to do, right? So if you again recollect, right, I'm keeping on going to refresh my embedding, right? If I come across a topic, like same analogy of a student, a book, right? I read a chapter and I want to relate it back to my other bookmark, right? I will give it a backlink saying that, okay, hey, this chapter related to a particular topic in physics is also related to, say, electricity, lightning, and so on, right? I'll link those two, correct? So if I have to kind of study from two different books and I have to create one reference page or a last minute revision guide, right? How am I going to do that? That is the role of that embedding service. It is going to keep on referencing and keep on getting updated with where my bookmarks should be. So far, all good? Okay. So,
Excuse me.
yeah,
Are you talking about the spectre space, basically, like increasing the dimensions?
correct. Correct. Yeah. Yeah. I was just trying to make it simple for the audience, right? But if you are into the advanced concepts, that's the exact way of working. Then comes the serving part of it, right? So if the serving, again, it's I would say not really the simple part of it, but the most scalable aspect is required over here. So I mean, it could be a web based interface, it could be an API. The integrations could be with anything like a Hugging Face, Vertex AI, Gemmas, anything, right? You can, again, for your own telemetry, all the logging monitoring is interfaced by that in inference server. Okay, so that is where, all the logging and telemetry would happen, so that you come to know, okay, hey, I did this XYZ activity while reading the book. I have read so many chapters today. This is what is my inference looking like, right? So that's more for my reference and my understanding, that okay, if something goes wrong, I'll have a thing to refer and say, okay, this is what I missed out, this is the chapter which is pending, right? So that is where the inference server comes in. Now, so far all good? A bit complex, right? Now, what all you can do with GCP, right? So almost practically everything, right? But there are means and mechanisms to achieve this even beyond GCP, right? On GCP, you can get TPUs, you can get GPUs, CPUs are of course available. But the important part over here, what I'm trying to highlight is the fact that, yeah, you get the inference and the serving stack within the GCP ecosystem itself, right? And you can have your own custom ML frameworks. You can integrate with these, ecosystem as well. So if you're talking from an Hugging Face or NVIDIA, in fact, I would recommend you should even try the Nemo guardrail framework, right? That's quite an interesting one with NVIDIA. Or, I mean, the traditional ones you can use something like VLLMs or the Hugging Face ones, right? Yes, I mean from the serving layer, it's really how you want to create your own ecosystem from a whether it's a chat interface or you just want to let it via APIs. It depends. It is so complicated. Is it really? Should we make it a bit simple? How many of y'all think ML pipelines or ML ops is very complicated? None. Wow, you all are good automation engineers, right? Anyone of you have used Cloud Run? Okay. You all feel Cloud Run is simpler deploying than GKE? Yes. Yeah. Why? It's a more one level above from a management perspective. You just have to specify your, your endpoints or your container services, your registry probably. Okay, and the serving takes care of it, right? So now with Cloud Run, it has started supporting GPUs, which means that the entire Kubernetes orchestration layer that we are talking about can be done even on a GCR, I mean a Cloud Run. Okay, CPUs can still behind the scenes be an NVIDIA, right? And you can still integrate with Gemmas. Okay, all good. Now, I mean, in the scope of this session, the demo could not be achieved, right? I mean, it's a. I mean, if I deploy something on Hugging Face, it will be a too long, right? So I have a lab guide for you. You can try it out at your home, right? Maybe if you want, you can. There are a few QR codes to scan. Now again, this is a QR code for a free ebook called Kubernetes Up and Running. I'm not sure if most of you all have it or not, but I would say it's you have it. Of course, that's one of the Bibles you should be reading if you are a Kubernetes guy. So this is courtesy VMware. They are providing it free in collaboration with Orally, right? And these are some of the links that you might want to go through, right? The second GitHub links is a complete source code for serving an LLM via Gemma, right? And the first one is basically a tutorial to kind of whatever we covered so far, right? Not really the RAG in depth, but if you have to deploy a Kubernetes cluster, deploy a VLLM container, and then run your chat interface on the Kubernetes ecosystem, the first tutorial will cover that entire piece, right? And yeah, there is a short video, a 4 or 5 minute video to explain that in depth. And there are a few other links. If you are new to Kubernetes, there is a GKE 101 guide that I have created. You can refer to that as well. Okay, captured this? Yeah. Okay. Uh, Probably just on time. If you can please fill up this QR code. It's a feedback for probably me and the organizers that, how did you like this session and so on. Probably only then you might get the swags. I'm not sure if Prem can support that. Yeah. So that's all from my side. Any questions, any discussions? I can still be around for the next 5-10 minutes. I have time to take some questions. Yeah. Okay. So yeah, any questions you would like to discuss? Probably if you are doing around AI, ML, probably even security. I don't mind. Yeah, yeah. Okay. So yeah. So again, just to simplify, right? LLM is basically a concept called large language models, right? It is just a framework, right, where you are kind of ingesting a lot of data and you are reading it word by word, right? It's tokenizing everything, right? VLLM is a layer on top of that, right? Which means that now out of that indexing, right, you consider it like a robotic way, okay, of reading, scanning an entire book, okay, and at the same time creating bookmarks saying that, okay, hey, this topic was present at page number X, this topic was present at page number Y. Okay, so it's a faster way of indexing. So the paging index that it creates, it's an advantage of VLLM as compared to a traditional LLM, right? So that's a fundamental difference, I would say. And VLLM is an open source library. It's available. You just search for vllm.io. You can kind of read through on that. Yeah. Okay. Any other questions? Yeah. Okay. Thanks again. Yeah, sure. We can take one more. Yes, it is for text. It's a text generation library. I mean, you're talking of VLLM. RAGs. Yeah, RAGs can be for any objects. I would say it can be for videos. It can be for images. RAG is not really limited to text. Nowadays, there are people who are coming up with image and video based systems as well. So there is no limitation as such. But the base inference, right, will be then tagged to text based inferences only, right? So if you look at RAG systems, the way it is going to generate the objects out of it, input prompts will be usually textual in nature. So that is why it's first linked with text and then with images and video. Make sense? I don't have anything on top of my mind. There are a few. I'll look up and probably I'll ping it to you separately. Yeah. Okay. Thank you. Thank you. You can connect with me on LinkedIn or Twitter. Okay. I'm on Dharmesh Vaya and at the red DR Vaya. Right. Then again, yeah, that's the QR for connecting with me. And yeah, that's all from my side. Thank you, everyone.
Give a huge round of applause for Dharmesh. Such a